Starting with the next question, which was asked in May 9 for 8 marks, will represent the data as per the master diagram. The top view of line AB measures 60 mm and is inclined at 56 degree to the XY line. So, top view length is given, which is 60 mm. So, from master diagram, we know AB, which is also equal to the plan length AB1. So, I can write AB is equal to AB1 60 mm. And this angle 56 degree is given for top view, means AB, angle made by AB with the XY line, means it is the apparent angle, and from master diagram the notation is beta. So angle of top view AB with the XY line is beta. So data is given for beta 56 degree. Point A is 10 mm above the HP and 20 mm in front of the VP, means again the point A is in first quadrant. So I can write A dash above XY and the distance above HP is 10 mm, and similarly A is below XY and the distance is 20 mm below XY. Point B is 45 mm above the HP and in front of the BP, but the distance with respect to BP is not given. But from this data I can say the point B is also lying in the first quadrant. With distance with respect to HP is given, so I can locate the front view, that is B dash is above XY and the distance is 45 mm, but we don't know the distance with respect to VP, so I can just say B is, that is the top view of point B is going to lie below XY. We don't know the distance here. Draw the projections of line AB. Okay. Now here the entire line is lying in the first quadrant, both endpoints A as well as B. So my solution will be similar to the master diagram. So we need to leave the space both above and below XY. So we have marked the reference line XY. I will measure the distances 20 mm and 10 mm on this vertical projector to mark the location of A dash and A. So this vertical projector should be exactly perpendicular to XY line. So first marking A dash 10 mm above XY, and A is 20 mm below XY. So we have marked A dash and A. Again, from the data given, we know the top view AB, which is 60 mm, and angle for top view, which is beta 56 mm. So I can directly draw AB at an angle beta, which is 56 degree. So for that, we know the point B is in third quadrant, so the angle we need to project is in the downward direction. So first I'll draw the horizontal lines passing through A dash and A so that we can measure the angles. So we need to measure the angle 56 degree in the downward direction, and we need to mark length of front view, length of top view, which is 60 mm. Be careful while measuring the angle. 56, so 50, 55, 56. So on this inclination of 56 degrees, we are going to mark length of 60 mm, which will give me the top view of line AB. So this will give me the end point B. Point B. So we have marked the top view AB. So from point B, I can draw a horizontal line which will give me locus of B. So this line gives me locus of B. Now here the true length is not given for that line, so we can't mark the true length to get the locus to get the point B2 on locus of B. So we need some other data. Now we have already given B dash is 45 mm above the XY line. So from this data I can say this locus of B dash will be a parallel line at a distance 45 mm above XY. Then only I'll get B dash 45 mm above XY. So on this vertical projector from XY line, I'll measure a distance of 45 mm and at that distance from XY line, I'll draw a horizontal line which will give me locus of B dash. So this line is nothing but locus of B dash, on which we are going to get both the points B dash and B1 dash. But again, for marking B1 dash, we don't know true length as well as angle theta. Again, we don't know front view length. But we know the top view length, which is 60 mm. So which we have already marked AB. But we know which is also equal to the plan length. So I can mark line AB1 plan length on a horizontal line passing through A, which is again 60 mm. So from A, I can measure the plan length, which is 60 mm. So this point will give me B1. Now we know from B1, if I drop a vertical projector, on the same vertical projector I am going to get B1 dash, which will also lie on the locus of B dash. So I need to just project this B1 vertically upwards up to locus of B dash to get B1 dash. So obviously this point will give me B1 dash. Now joining A dash B1 dash will give me the true length in front view. So A dash B1 dash is giving me true length. This AB1 was the plan length and AB is the top view of line. Now using the same true length in front view, the notation is A dash B1 dash. I can mark the true length in top view also, the notation for which is AB2. So taking the same true length, I know the locus of B, so I'm going to get the point endpoint B2 for true length on the same line. So I'll cut the arc of true length on that locus. So this is going to give me point B2. Okay. So we have marked true length in both front view as well as top view. So now the remaining part is marking the front view length, which is A dash B dash. So again I know A dash B dash is equal to front view length, which is not given in the problem, which is also equal to the elevation length A dash B2 dash. But we have already marked B2, so we know that B2 dash is going to lie on the vertical projector from B2, which is produced up to a horizontal line passing through A dash. So from B2, I can drop a vertical projector up to horizontal line passing through A dash. This will give me the corresponding front view of B2, which is B2 dash, and AB2 dash is nothing but the elevation length, which is equal to the front view. So we can take elevation length in the compass and produce an arc up to locus of B dash to mark the final front view, which is B dash. So we have got this front view of the line AB, which is A dash B dash. Okay, and top view we have already marked AB, so we will make those lines dark. Okay, instead of following this procedure of marking B2 dash from B2 and then producing R, we could have directly produced B up to locus of B dash, because we know from the test of correctness that B and B dash are going to lie on the same vertical projector. So we could have easily marked B dash just producing B upwards up to locus of B dash. Now here we have not done that because we need to check the test of correctness, that is B and B dash should lie on the same vertical projector, so which is satisfied here, but we could have done this also. So now nothing is asked, like we did not find any did not measure any angle or true length, so we will just show them notations. This is front view A dash B dash and AB2 is true length. This angle is theta, this angle is phi, angle made by true length. Then the data with which we have started is beta, which was this angle. So beta is given as 56 degrees and this angle is alpha. Okay, so this completes the solution. For extra information, you can measure these angles theta and phi and write the values there, so that examiner can verify with the answers. But since it is not asked in the exam, in the example to measure any angle, so we are not measuring it here. So this completes the solution for this problem.